Okay, so what in the last couple of classes we were talking about this idea of the tangent line, and so what we're interested in today and the next actually for the rest of the unit kind of is we want to find the slope or the gradient of this tangent line. How do we find that given a specific function and a point on that function? So today we're going to have to go a little old school. It's going to be really tedious. They somebody ask it on the IB exam, but in general, you can use the formulas that we're going to be coming up with. Today, though, we have to, as I said, we have to go old school, first principles. So how do we? So we don't have a tangent line here. We have a secant. So what we're going to do is, once again, I said the function was y equals x squared, and I'm going to find the slope between, let's call this A1 and B. So A1 we can see is 1, 1, and B is 2, 4. So we know it's 3 over 1. So the slope of this line is 3. Okay, so what I'm going to do though is, that was A1. Well, I want to know the tangent, right? So I'm going to move A little closer. So let's literally move A up to 1.5. Now we still have a secant, because if we zoom in there, well, it's not the same point. It passes through 2 points on the curve. Let's call this A2. Okay, and A2 is 1.5 comma 2.25, and B is still 2, 4, right? So what do we have here? So it's a 1.75 over 1.75, and then the change from 2 to 1.5 to 2 is 0.5. So hey Siri, 1.75 divided by 0.5.
1.75 divided by 0.5 is 3.5.
3.5. Okay, let's continue another time. Let's move it up to like an A3, and I'm going to move my A3 up to, let's move my A3 up to, like, let's get really close, right? Let's go to like 1.9. Let's go to 1.9. So once again, let's call this point A3, and I'm gonna. So this was A1. This was A2. This is A3, and so it's a 1.9. Hey Siri, 1.9 times 1.9.
1.9 times 1.9 is 3.61.
And my B is still 2, 4. And so, hey Siri, 4 minus 3.61.
4 minus 3.61 is 0.39.
So 0.39. And the denominator, that's 2 minus 1.9, that's 0.1. So we know it's 3.9. Now, the question is, what are we theoretically doing? Well, theoretically, we're moving that A up to the B position, right? So let's do that. So we move it up there, right? And now we have a tangent. It's technically the same point, but we have a problem. What's the problem? So you say, well, Mr. Adler, it's the same, but like A4, if we call this new point like A4 is 2, 4, and B is also 2, 4, and then it's like we have 0 over 0 as the slope. But everyone's like, wait a minute, like you're looking at that line, like you know that tangent has a slope. So what do? It's 0 over 0. So this is where we use first principles. So let's rethink about what we did. So you can make a screenshot. I'm gonna erase all of this except for the curve. I'm gonna get rid of all. Let's get rid of it. Let's get rid of this. Let's put that back. The graph back. Grid form. Put the grid back. Let's move it over. And let's put the function back in. We said it was new function. It was y equals x squared. So it could be any function, but we're going to put our x squared back in. And let's plot the function. And let's zoom in a little bit. Let's see what's going on. What did we do? So let's zoom in. Sorry about that. Let me change the grid from a rectangle to a square. And then I want to zoom in. So what did we do? So the idea is this is the theoretical idea. We knew that we had a point. We knew that we had a point here. Sorry. We knew that we had a point here. Let's call this x. And then we have another point up here. And let's call that x plus h. And we had a y value here. We're going to call this f of x. And we had a y value here. We're going to call this f of x plus h. Sorry. And what we did was we first, to find the slope of the tangent line, we had the change in y over the change in x. Right? That was the idea. Very straightforward. But what did we do? We moved the x closer to the x plus h, which means we wanted to see, what we want to do is the limit as x approaches 0. That's the theory. Once again, we had two distinct points. They were separated by an h. But what we did was we kept moving these points closer and closer so that the h inevitably was 0. So what we're going to do is the same idea. So we want to find y equals x squared. We want to find the derivative of y equals x squared at any x and x plus h, and we're going to move them together. So the idea is we want the limit as h approaches 0 of x, of x plus h squared minus x squared over x plus h minus x. So we have, I'm sorry, this is a little sloppy. Oh, stop. There we go. So we have x squared plus 2xh plus h squared minus x squared over over h. Sorry about that. We continue on. Now we have 2xh plus x squared, h squared over h. We cancel out the h's. We have 2x plus h. And then as we set h goes to 0, we see that the answer is 2x. How does that connect back to what we did? Well, if you recall, the numbers kept getting closer and closer to 4. And so when we plug x in for 2, when we plug x in it equals 2, we get 2 times 2 or 4. And that's the idea. So we saw in the video that we saw in the video that we were trying to find the equation of the tangent line, the slope of the tangent line. And so we started off with our original function of, it was y equals x squared. And this idea that we brought 2 points together, we started off with 1. This was A, this was B, this was 1, and this was 2. And the idea that we moved 1 closer to 2. So originally we had a secant, which we could find the slope, and then our theoretical goal is to move A so close to B that we actually have a tangent. We had a tangent. And that's our goal. So our goal was to find the slope of that red line. And so now let's take a look at this mathematically. Let's take a look at this mathematically. So the first point we want to find between A, which is 1, 1, and B, which was 2, 4. So we found the slope between, let's call the first A, which was 4 minus 1 over 2 minus 1, and that was 3. Then we moved it a little closer. I think the next point we made E2, I think we moved it to 1.5. So we know that 1.5 squared is 2.25 and 2, 4. So the slope between the second point, which was closer to the B, and the B is, what do we have? It's 4 minus 2.25 and 2 minus 1.5, which is 1.75 over 0.5, and that's 3.5. Okay, we're getting closer. I think we moved it a little closer. We let A3 be like 1.9. So we had 1.9, and what's 19 squared? It's 3.81. And B is still 2, 4. We're getting closer. So we have 4 minus 3.81 divided by 2 minus 1.9, and we have no, 3.61 and 1.9, and we have, what is it, 0.39 over 0.1, which is 3.9. So we can even get even closer. So what we're seeing is that it's approaching 4. This slope, it's approaching 4. So, well, let's take it to the next step. Theoretically, what are we doing? We're bringing A closer to B. So let's take it to the final destination, which is that A4, let that be 2, 4, and B be also 2, 4. So we found the slope of the fourth point, and we get, 4 minus 4 over 2 minus 2, we get 0 over 0. And for years, that's a fun question in, kids you can't divide by 0. More importantly, it's what happens when this shows up? Well, here's a situation where 0 over 0 is showing up, and the question is, what does it mean? We know there's a slope here. We know the slope is not 0 over 0. We know it has a slope. We know it's positive. We know it's 4. But how do we get 4 when it's 0 over 0? So the idea is that we're going to use first principles. So save this. I'm going to erase that. Okay. So let's think about what we did theoretically. So what we did was we started with our graph. It could be any graph. And we started off at a point x and another point x plus h. It was a little bit more, right? Let's just be clear, right? What is the value of this function right here? Well, that's simply f of x. And what is the value of the function up here? It's f of that value, which is a little bit larger than x. It could be a little bit or a lot. The difference is h. Okay. Right? Let's move on. And I don't like this marker either, so I'm throwing this away. What did we do? Well, we were interested in finding the slope of the line, right? We wanted to find the slope of the line between these 2 points. So the slope between the 2 points is change in y over change in x, right? We're following through, we're just following through the logical, right? But there's a little addition, because what happened, what was going on with the h? We saw the h was getting smaller and smaller till these 2 points were the same. So the idea is we want to find the slope when the limit as x approaches 0. Well, what does that mean? So let's follow through on our original function. So we claim that the slope of the tangent line of y equals x squared at x equals 2 is 4. Let's figure that out. So the slope of the tangent line, so we're going to say x plus h squared plus x squared over x plus h minus x. That's what was going on here, right? I'm going to leave the limit off for a second. Let's expand this out. Well, we know what x plus h squared is. It's x squared plus 2xh plus x squared, minus x squared over x plus h minus x. This simplifies to 2xh plus h squared over h. I'm going to factor out an h, right? So this becomes 2x plus h, and the limit as x goes to 0, what happens is to this expression as x gets ridiculously small, it goes to 2x. Now, this actually gives us the formula for the slope of the tangent at any point. But in the first problem we did, we looked at it at x equals 2. So at x equals 2, the slope of the tangent, 2 times 2 equals 4. That's where 4 comes from. And that's the idea. So